Hello, hi everyone. My name is Rupeng An. I'm a professor at New York University, and I would like to show in a number of a sequence of YouTube video recordings how we can leverage the power of LangChain to construct retrieval-augmented generation or RAG system that can leverage the power of large language model and ground the large language model in the vector database, the vector store that we built. Um, I anticipate to be a number of YouTube videos to systematically demonstrate how you can use LangChain, the most comprehensive and state-of-the-art um, ecosystem to use a large language model to build RAG applications. The full credits go to this amazing book by Mayo Oshin and Nuno Campos. The title of the book is called Learning LangChain. By far, this is the most extensive and well-written book to introduce the LangChain ecosystem that I know of among many other textbooks or tutorials. The book is still under active development, but if you are an O'Reilly Media user, you should be able to access the very first draft of this book. I think the author has completed a total of 6 chapters. There probably are more to come. Uh, so uh, Basically, we went over this book chapter by chapter, and then demonstrate the capacity of LangChain using some examples of that book and also some of our own examples. So let's get started. In this video, we'll show you content in chapter 1, which is the LLM fundamentals with LangChain. First, you need to first let me introduce briefly the system we use. There's nothing wrong if you want to use your VS Code or Google Colab, but I find this platform amazing. This is the um, the online system that you can run um, VS Code and other or say Jupyter Notebook and other platforms online, completely supported online. Is called Lightning AI or Lightning AI Studio. Uh, you can apply for a account for free, and it gives you the capacity to build multiple documents, either the IPYNB file, the Jupyter Notebook file, or the Python code py file, etc. It's like you have an online cloud version of your VS Code. Advantage of using that instead of using your own VS Code in your local machine is that you can easily share the code and work with your team building applications. And it can also publish your code immediately, share with the Lightning Studio community, and also it support uh, not only VS Code and Jupyter Notebook, but also TensorFlow, and you can even build your web applications and immediately deploy that to the cloud. Although I haven't tried, but I think that's a wonderful application. And now we may later on shoot a separate video just showcasing the Lightning AI Studio. But now let's focus on the LangChain. So in this episode, I'm going to show you how to work with the basic functionalities of large language model with LangChain. So let's first import some libraries. I'm going to import the LangChain together with subsidiary libraries such as LangChain OpenAI, LangChain Community, and LangChain Text Splitters. So after import these libraries, what is nice about Lightning AI is you won't have to install it every single time. That's in Google Colab. It's going to be stay in your studio. As one studio is like you can think of as a VS Code folder that store all your files. Um, and it creates its own virtual environment and it's perpetual. So next time when you open the studio, you won't have to install these libraries again. And after installation, we can import the modules. We are going to import some basic modules, the OS and the .env for later on importing my OpenAI API because we are going to use OpenAI models. And then I'm going to import a few functions from LangChain, such as the OpenAI, Chat OpenAI. This is going to give you the capacity to work with the large language model and also the chat version of the GPT models. And then I'm going to import some functions, AI message, human message, and system message, which will be very handy when working on working with the OpenAI API to supply the system message, the human message, and also the AI message. And later we'll also use prompt template and chat prompt templates, which are going to create a template, the prompt template for us that can be used in different settings. And we also are going to have this the comma separated list output parser to parse the output from large language model. And then we are also going to build our very first LangChain, a chain. Basically, chain is just a way that we can combine our prompt with our language model, later on with retriever as well, to build this RAG pipeline. And we're also going to use base model and field from Pandatic, which is the way in Python to allow the large language model to produce data in output in the required format. As we often know that large language model tend to produce outputs that are not that are have a variety of different type and may not always suffice your need. So the Pandatic will allow you to check with the model output and make sure that it comply with a certain format, maybe a CSV or maybe a JSON, etc. Okay, so let's import those modules. And then I use the load.inf to load my OpenAI API. My OpenAI API is stored in the .env environment. And for security purposes, I'm not going to show you that file, but basically that is where you store your OpenAI API key. And then you can just call that P and set that into your environment. So you set your OpenAI API key by calling that environment. So we're going to do that. And now we can use the LLM with the LangChain. First, we need to call a model. So here I'm going to use the GPT 3.5 Turbo Instructor model. Is a small model that is very inexpensive, great for test purposes. So I'm going to use that model. And then because you already provided the API key to OpenAI, so you don't need to provide API key here. You just need to call a model name. Um, and so notice one thing is that OpenAI, so this is only going to work with the large language model, but not with the chat version of the model. If you want to use, say, GPT 3.5 Turbo, then you need to use the chat OpenAI function. So that is going to bring up your chat-related models. And then that's invoke this model. Invoke is just means use the model to make an inference. I write the prompt, what is the meaning of life? And then I just call this model, invoke this model. Invoke is universally used in LangChain. And previously, you may use .run to run the model, but now I think run is deprecated, and you should use invoke to activate the language model or any chain that you build later on. So let's do that, and let's take a look at the response. The response is the meaning of life is a philosophical question that has been debated by various thinkers throughout history. Some believe that life has a specific purpose or goal, while others see it as a journey to find personal fulfillment and happiness. Blah blah blah. So this is the model output. Nothing surprising, hopefully. But now let's build a little bit upon that, and we showcase how you can use the chat OpenAI model. To use the chat model with LangChain, it asks it required a human message. A human message is the message sent from the perspective of the human, basically our user. And then an AI message. An AI message is a message sent from the perspective of AI that the human is interacting with. You could think of this as an assistant role, right? The AI assistant. For example, if you chat with OpenAI, with ChatGPT, the ChatGPT say, "No, I'm your assistant. Let me know how I can help." Right? So that would be an AI message. And then besides that, it also has a system message. So system message basically guard the overall behavior of that agent. Um, Basically that particular chat instance. So for example, usually the system message would be you are a helpful assistant, right? So basically assigning the role for an AI agent, in this case, a chat GPT agent. And then you could also supply a chat message, basically a message allowing for arbitrary setting of role, if you like. But mainly you are dealing with a human message, an AI message, and the system message. So here, let's use the chat model. We use GPT 3.5 Turbo, and we can create a human message. You just need to call the function human message and then supply what message you want to convey. So here we say, what is the capital of Japan? And then you have the human message. You don't need to have the system message because you can just use the default. And then after completion, we'll be able to see the AI message generated from this chat model. So let's invoke this and take a look of the model output. So the model output here is in the JSON format. We have the content. The capital of Japan is Tokyo, but we also have additional arguments here, some metadata, etc. We are not really go into details of that. So it gives you a lot of other inputs besides the content. So we are only interested in content, so you can just call completion.content to just extract the content from the JSON output. And that content is the capital of Japan is Tokyo. If you want, you can guide model behavior by adding a system message. For example, here, you add a system message. It says you are a helpful agent that responds to questions with 3 escalation marks. And then if you add that system message is to guide, use that principle upon all the responses that you are going to get from the AI message. So for example, in this case, if the human message is what is the capital of France, and then you invoke the model by providing both the system message as well as the human message. Um, Here, I think the order matters. You want to have system message first and then followed by human message. And then when you do that, uh, the output would be the capital of France is Paris, and then the system the chat model add 3 escalation marks at the end, which is governed by the system message. Okay, and now let's show how you can use the prompt template that we mentioned. So prompt template allow us to create basically a template that we can reuse. We can use and reuse many times. So we won't have to provide every single time a complete message. We just need to provide the content that we can embed in this prompt template. So here is an example. You use the prompt template, and then you use the function dot from template, and then you can provide your template. You can say whatever you want for the template, but the reusable part must be within this parenthesis, okay? This curly parenthesis, because otherwise you cannot reuse this part. So you could consider this just as a variable that you can embed into the template. You can switch no different variable values. So here, the template is answer the question based on the context below. If the question cannot be answered using the information provided, answer with I don't know. And then you provide the context, you provide the question. So the context and the questions are the 2 variables that you can later on supply. Okay, and after that, you can call this template so that the specific values for the context and the specific value for the question will replace in these 2 places. Okay, so that is how you use a template. And then you can provide your context. So here I provide the context as a string variable. I said that a utopia typically describes an imaginary community or society that possesses highly desirable or near perfect qualities for its members, blah, blah, blah. Basically, I copied this from Wikipedia regarding definitions for utopia and dystopia. And then I wrote my question as another string variable. When was Abraham Lincoln born? So I intentionally made this so that the question and context, they have no overlap whatsoever. And then I invoke the template. Invoke template basically is using the values for the context and question to replace in the respective places in the template. Okay. When you invoke the template, you can take a look of the prompt created out of this template, and not surprisingly, you still have this sentence. Answer the question based on the context below, blah blah blah, and then you have the context here, the utopia definition, and you have the question here, right? So basically, it just replace the context with the context variable definition, and also replace the question definition here. Okay. So that is how you create a prompt using a prompt template. And then that's feed the prompt to the large language model. So here we have the large language model. We invoke the model by providing this prompt. And then when you print the completion, sorry, I haven't really invoked this. And then when you complete it, the model would output I don't know, because the question, the answer to the question is not within the context provided. Okay. And now let's try to build a chat prompt template. Remember, the difference between a chat template and the and the LLM template is that for the chat template, you want to provide the system message, the human message. So in this case, I use the chat prompt template, and then I use the from messages function. And in that, using a list, I provide the system message. The system message is answer the question based on the context below. If the question cannot be answered using the information provided, answer with I don't know. And then I provide two human messages. One is a message pertaining to context. The other is pertaining to the question. So when you invoke this chat template, you should be able to tell that now I'm going to replace the context and replace the question with their specific values. Okay. Okay, so let's do that. We've created this chat prompt template. And now when we invoke the template, we need to provide the context. We need to provide the question. I'm still using the previous defined context and question values. And after that, I can provide this this prompt to our chat model. Remember, we created a chat model using OpenAI's GPT 3.5 Turbo. And after that, I print out the model output, and the model output, not surprisingly, is I don't know, right? Because again, the answer to the question is not within the context. Right? Okay. And then I'm going to show you briefly how you can use the Pydantic to ensure the output is in a certain format. Okay. So no, first I'm going to use the base model from the Pydantic module. And then I'm going to build a class to define the specific format I would like to have for the model output. Okay. So I create a new class. It's called answer with justification. And then I use the base model as the parent. Basically, it's going to adopt all the functions from the base model. And so this template is going to use the following format. Follow the following format. Okay. So first, it's going to show answer. So an answer is going to be a string variable, and then it's going to show the justification, and justification is also a string variable. Okay. So basically, we create this template, and then we are going to guide the model output to comply with this formatting specified in the template. And now let's try out whether it is successful. We create a prompt, and the prompt is, could people go back in time and change history? And then when we call the chat model, instead of using the directly invoke the chat model, I first specify this chat model use the function with structured output. Okay, so this is going to tell the model that when the model make inference, make sure that the inference follow a template. And then I'm going to supply that template we created is a class using base model as the parent is answer with justification. And then after that, we are going to use this new model instance, structured chat model, to invoke that using the prompt we have. And then let's take a look of the output. Okay. So let's run this, and we see that the answer is answer. Okay, the response is answer equal sign. No, it is not currently possible for people to go back in time and change history. And then we have justification equal sign. Time travel is a concept that has not been scientifically proven or achieved. While it is a popular topic in science fiction, there's no evidence to suggest that time travel is possible according to our current understanding of physics. Okay. So it seems that no, the output does strictly follow our template, right? So answer first, string variable, and then justification, right? So nice thing about this is that you can now extract only the answer or extract only justification because this is a JSON file, right? So in this case, we can just call structured output dot answer to get just the answer piece, and we can get the structured output justification dot justification to get just justification piece. This is really nice, right? And we can also use the parser to pass the format in a specific format, for example, CSV or XML. So this parser can be really helpful sometimes for you to get a specific format of the output model output. So it is an alternative to the pandantic function. For example, you can call the comma separated list output parser. Basically, is going to create you can pass the output into a list of strings in this case. So for example, I call this parser and I invoke, I'm going to pass this string. The string is 1, 2, 3, 4, 5. Then when you print the output, it's already parsed into 5 elements, 5 string variables, string elements in a list. Okay. And now let's switch gear a little bit and take a look of the runnable interface. Okay. So a common LangChain interface can be initiated using these methods. Okay. So 3 methods, in fact. The first one is invoke that we already experimented. So invoke basically transform a single input into a single output. Okay. So it's for for individual use cases. And sometimes it is more efficient or useful to transform multiple inputs into multiple outputs in one go. And we know that it's called batch, right? So therefore, we can use the runnable interface batch to process simultaneously many inputs and output multiple outputs in the same time. And the third option is managed chatbot implemented. It's called stream. Basically, the stream output when it is produced at the same time is going to show up. Okay. Um, so we know how the large language model work is the word by word or token by token it make prediction. So the stream allow us to print out the output as it is created. So that's first experiment with Invoke. You've already seen this. We have a chat model, Chat GPT 3.5 Turbo. We invoke with the prompt "Good morning," and then we get a feedback. We get a content output. "Good morning. How can I assist you today?" How about we use the batch mode? You can call chat model.batch. In this case, in the list, you can provide more than one prompt. Here, I provide two prompts. The first prompt is, "How are you?" And the second prompt is, "What is up, bro?" And then the output is also a JSON file that in the JSON file, there's a list of two content. And they are you can use index to call them individually. So I call the first index 0, and also call the second index 1. And then you should be able to see that the first contents is the answer, is the response to the first question, "How are you?" The answer is, "I'm just a computer program, so I don't have feelings or emotions like humans do. I'm here to help you with any questions or concerns you may have. How can I assist you today?" And the response to the second prompt, "What is up, bro?" Is, "Hey there, not much, just chilling. How about you?" Right? So that is very neat. And we can also showcase the stream interface. You can call stream in this chat model. Say I provide the prompt "see you." Um, and then because stream is going to produce token by token, word by word. So in this case, you can use a for loop to show as the content is created. Okay. And then in this for loop, you just call this token by token. I would say for token in this output, please print the content of that output. Okay, so let's take a look. It's going to show this, although it's very fast, but it's going to actually show one by one. It's "Goodbye, exclamation mark, have a great day, exclamation mark." Okay. Okay, and now we are ready to combine the different large language model components. And there are actually two ways to do this. So LangChain is called chain because we combine the prompt with large language model and maybe parse the output, and later on we are going to build retriever on top of that. So the chain can become complicated. And there are two ways to combine different LM components. The first way is called imperative. Uh, Imperative method basically is just you build a function. And then later on, you invoke the function, and the function is going to have combine all the components. And that is the way that we are familiar with. It's like any function that had multiple components, and we are going to process the data in the function and then produce an output, right? But here, the only difference is that we are going to use a decorator chain here, a decorator chain, so that the function we build can be invoked. Basically, the function become a runnable by a LangChain. So the imperative, I would say, is more of a Pythonic way to build a pipeline. Is explicit. It can deal with complex chains. But the downside is it's a little bit wordy, right? You have to write out this function, one by one, define intermediate outcome, etc. And so the LangChain comes with another way. It's called the declarative method. or it's called more precisely declarative with LangChain expression language, or LCEL. And it uses pipe to combine different functions together. So the language is not very Pythonic, but I would say it's easy to understand and very succinct. Because you won't have to write all these intermediate functions and name them. And it's not that flexible in comparison to imperative method, but it is more convenient. So down the road, it's really up to you which way you want to build the pipeline, the imperative method or the declarative method. So I'll show you both ways in this tutorial. First, let's see the imperative approach. So nothing surprising. We need to first build a chat prompt template in this case. And we supply the system message, your helpful assistant. I supply the human, which basically pose a question. And then we call the chat model, the chat OpenAI model. I think the default probably is just the GPT 3.5 Turbo. And then I'm going to build this function, right, that we mentioned. And it is an ordinary function. The only difference is that now we use a decorator chain. And the chain decorator will add the same runnable interface for any function you write. Remember, there are 3 runnable interfaces. Here, the invoke, the batch, and the stream. Okay, so any function that is written using the chain decorator will be able to will be able to run, executed using either invoke or batch or stream method. Okay. And then the chat function is pretty simple. We just the input is the question itself the user provide. And then based on the question, we are going to build the prompt using the template. And then we are going to invoke the chat model. That's it, right? Let's test out this. We have a question. What is the key difference between stemming and lemmatization? Okay. And then remember, you need to invoke the function. Okay. So common mistake that I made many times is I would call chatbot and then question. That's not going to work because now it is not a traditional Python function. It is a chain function, so that you need to use either invoke or batch or a stream. Okay. But other than that, it's just a function. Okay. And then let's run this and print the results. It says the key difference between stemming and lemmatization is that the stemming involves reducing words to their root form and removing suffixes, whereas lemmatization involves reducing words to their base or dictionary form known as lemma. Okay. Blah, blah, blah. You can read the rest. If you want to build a streaming chatbot using imperative approach, you can. You still remember to use the decorator chain, and here you still create your prompt using the template. The only difference is here because now you are producing token by token because you are using the stream method. So therefore, you should use the for loop. And in the for loop, you just use yield. So yield is going to basically produce the content as they become available. Let's try out this streaming chatbot function. So I provide a question, which planet is closest to the Earth? And then remember this time, again, you should use chatbot.stream to invoke this, to run this function, rather than just calling chatbot question. So if we run this, well, it printed out the output one by one. The planet closest to Earth is Venus, period. Okay. So actually, you can do even more. You can use asynchronous function, build an asynchronous function on that. So asynchronous function could be useful if you have a set-aside function that you don't want to interfere with other functionalities if you're building, for example, a web application. So you can use the async when you define async function. I think no, even in the regular Python, you also define an asynchronous function like this. So there's nothing specific to LangChain. And then you need to use await every time you initiate any function within the asynchronous function. Okay. And then also you use this A invoke, stand for asynchronous invoke, when you invoke a template or invoke a chat model. Right? And say here we test out, the question is how to put an elephant into a fridge. Okay, so let's try out this asynchronous function chain. And the output is put an elephant into a fridge is not a practical or ethical thing to do. Elephants are large, blah, blah, blah. This seems to be very different than the previous response I got, which is more entertaining. So this is probably too serious and lack of humor. But anyway, large language model is fundamentally stochastic, so we really don't know what we get. Okay, so after we show the imperative method, which basically allow you to create chain decorated functions that show you the second way you can create a chain by combining different LLM component, and that is called the declarative approach using the pipe. Okay, so the declarative approach actually is very simple, and people love it. It's not very Pythonic, but it's the LangChain way of building pipelines. Okay? So we call this this symbol a vertical line as pipe. Okay, and as long as you have the template and you have the chat model, you can combine them together just by using call this pipe. Okay. So this way, basically, the interpretation is that the output from this template is going basically a prompt, right? Is going to be fed into the chat model as the input. Okay, this is the interpretation. Let me say again, the output from this template is going to serve as the input for the chat model. Okay, this is how we chain it. Okay. And let's try this out. So I built this chatbot. I previously defined the template, so I won't have to redefine it. I also defined the chat model, so both are previously defined. Now I just need to chain them together using the pipe, and now I can invoke with the chatbot. This time I posed a question: who is the current president of the United States? And then it gives me the answer. Of course, the model is kind of obsolete. So it says, as of October 2021, the current president of the United States is Joe Biden. Well, it's still technically correct because we are 1 week away from the presidential election. Okay, and then you can also use the declarative approach with the stream as the runnable. You build the chatbot in the same way, combining the template and chat model with pipe. But this time you call stream, and remember always to use a for loop if you are using stream, and then you just print the content as they become available. So the question is good evening, and the output is good evening, exclamation mark, how can I assist you today, question mark. Okay, pretty good. Again, you can also use the declarative method for asynchronous execution. Everything remains the same, except now you use await and you use invoke to asynchronously invoke the chatbot. So if I ask question, what is the capital of Australia? Well, it got it right, and not surprisingly, this is a simple question. So it's really up to you whether you want to use the imperative approach, which that you build function is more explicit, it's more Pythonic, but it's a little bit wordy. But if you want to build this using the declarative approach, by using pipe to combine different components together, it is very succinct, not very Pythonic, and it's great for relatively simple chains. Okay. So that concludes the very first tutorial, and keep I will send I will in the show notes I will give the link. You can download the code from GitHub, and we'll continue. So it's going to be a series of tutorials, and in the next session we're going to talk about the indexing corresponding to the chapter 2 of the fantastic textbook called Learning LangChain. Thank you for your attention. I'll see you soon.